Okay, next we're going to talk about how to graph a system of inequalities. So remember, system just means we have more than one inequality. Sometimes we're going to graph 2, sometimes we'll graph 3. In this case, we're going to stick with 2, and it's already in slope-intercept form, so we don't have to do any extra work to get y isolated or by itself. Now, a few things I want to point out. Up here in purple, we are going to use a dotted line as we connect our points when we have a less than symbol or a greater than symbol. Think of a dotted line representing an open circle when we graphed inequalities on a number line. In the same way, if we have the equal to symbol, which would represent a closed circle, when we go and connect our points with a line, we're going to use a solid line for those examples. We'll talk about shading above and below here in a moment. So let's go ahead and just graph this like normal, ignore our inequality symbol, and graph it just like it's an equation. So I'm looking for my y-intercept, so we're going to start up 3 on the y-axis. So on my y-axis, 1, 2, 3, I'm going to put my starting point. So remember, y-intercept a lot of times is known as a starting point. From there, from that starting point, here are my directions. I'm told that I need to go down 2 and to the right 3. So down a distance of 2 and to the right 3. Down 2, right 3, and so on. Now, again, if we would have run out of room on our coordinate plane, instead of going down to right 3, I could go up to left 3, and it would still be a line. So up to left 3, up to left 3. This is where you're going to want to pay attention to the symbol, so that we know, do I connect these points on this line with a dotted or a dashed line, or am I going to use a solid line? So let's look at our symbol here. We have the less than or equal to symbol. Because of that equal to symbol, we are going to connect them with a solid line, similar to how we would do that with a closed circle. And so again, that goes on forever, so we're going to attach arrows to the end. Now, what about this here in blue? This is the less than symbol. When you think if something is less, you think it's below or underneath. So when I find my less than or equal to symbol here, we're told that we're going to shade below the line. So I'm saying that all of these coordinate points underneath this line, below this line, are going to be solutions to this one inequality. But I don't want just the solutions to one inequality. I want solutions to both inequalities. So we have to now go ahead and graph line 2. Let's go ahead and just label this. We're going to label this line 1, just so that we can keep track. I'm going to use a different color for line 2. So I'll use blue up here. So this will be line 2. Again, it's already y equals mx plus b. So my starting point is positive 2. So I'm going to go up 2 in blue and put my starting point. From there, this is a negative 1x, meaning that I'm going to go down 1, right 1. So down 1, right 1. And that could go on forever. And the opposite direction of down 1, right 1 is to go up 1, left 1. And we see that they're going to intersect right there at that point. Now, before I connect the dots, I want to look at my symbol. So because my symbol does not have an equal to symbol, I am going to have to use a dotted line to connect these points. So as I connect these with a dotted line, that goes on forever. We see their intersection point right here at negative 3, 1, 2, 3, 4, 5. That was important for equations, not quite as important necessarily for inequalities. But now, what about the shading? I want to shade above the line because it's a greater than symbol. So I'm going to shade above this blue line, meaning all of these solutions here would be solutions to this inequality. Now, what happens is when you graph these, what is created, it's split into 4 sections. So we have this little tiny triangle here where nothing is shaded. We have this area here where only purple is shaded, kind of outlined by the purple solid line and the blue dotted line. Then we have this up top, kind of outlined by this blue dotted line and then connecting to the purple solid line where only the blue is shaded. We want to see, where does the shading overlap? It only overlaps here in this little triangle segment right here, where blue and purple overlap. So that means all of this area right here is a solution to both inequalities. We have purple being shaded because it's below this purple line. We have blue being shaded above that blue line. So all of this underneath purple and above blue is going to show us where our solutions